Bonsuelo, athletes! This is going to be great. This is going to be great. What we're going to do today is solve quadratic equations by completing the square. And you say to me, Mr. Lieblang, haven't you already completed the square? And I say to you, yes, we have, but not to solve an equation. You go back and look at when we completed the square. And what did we do? We changed the form. We changed standard form of a quadratic equation into vertex form of a quadratic equation. Now, so what are we doing here? I want to make sure you understand what it is we're doing, because it's not enough to know how to do something. You have to know when to do it. So what I want to do is compare a couple things, first of all. Okay, first of all, take a look at these two equations, all right? They're both linear equations. X, the variables to the first power. But if I gave you a quiz, probably what would you do with the first problem and probably what would you do with the second problem? If I didn't give you any instructions, now I realize you could do several things with the first one and with the second one, but probably what would the instructions, most likely, would the instructions be for each of these? And the first one, I hope you know, would be what? Think about it. It would be graph. The second one would be solve. Why? What's the difference? The fact that this is y equals and the fact that this is 0 equals, okay? The first one you would probably graph. You'd graph a line. The second one you would solve for the variable. And it's just, now, I realize on the first one, I could ask you to find the x-intercepts. I could ask you to find the y-intercepts, blah, 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 blah. But, most likely you're talking about graphing on the first one and solving on the second one. Okay, that's fine. And you should know how to do those. How about this second problem? Well, what we've looked at so far is this, okay? And what did we do with that? Now, I asked you some questions about them, but basically what we did is we graphed it, okay? And now we've also looked at this, and basically what did I do with it? You solved it. Now, they're both quadratic equations. They're both squared, okay? Well, which one have we completed the square for already? This one right here. And what we did is we took it, we completed the square, and we changed the form. Now, the second one we've done also, but what did we do with that? We solved it. We solved for x. We got x by itself. So just to show you, this is not what we're doing today, but just to show you, like, how these things differ, okay? What you'd end up with in the first one when you change the form. Now, yes, we can graph it, and that's what we do, but at various times I've asked you to find the intercepts. So when we completed the square for the first one, this is what we got. We took y, we separated the 7, then we cut this in half and squared it, which gave us, and because I added 9, I had to subtract 9 at the same time, and then we factored it. Okay? That's what we did. So we just changed the form, and then I could ask you to graph it. Well, what did we do here? We solved it, and what we did is we factored, set each factor to 0, and you get x equals 7 and x equals -1. Look at the way the answers look. Now, I realize on the second one I didn't complete the square because I haven't shown you how to do it yet. But on the first one, notice you've got y equals. On the second one, you've got x equals. Why? What's the difference? There's no y in the second one. Okay, you're trying to get x by itself. Whereas in this first one, you're completing the square to change the form, okay? Well, what are we doing today? We're going to complete the square, but to solve something. So yeah, we're going to complete the square, but the answer is not going to look like the one on the left. It's going to look more like the one on the right when we're done, okay? So just want you to be aware of that fact. Now, I'm going to go through some problems, and I'm going to go through them fairly quickly because I want you to be aware of something, okay? So let's just solve these. Let's solve all of these. Okay, what I've recommended you do is not take the square root, although that's a legitimate method, is set it equal to 0, and then we'd have factor it. And then you have x equals 5 and negative 5. Okay, here, second one. A little more bizarre, but set it equal to 0, and now factor it. And you're saying to yourself, self! We can't factor that because that's not the difference of two perfect squares, but actually you can factor it. Remember the way, now with what I've shown you before, you couldn't, but remember the way you factor. First term, last term, check with the middle. So let's look at the first term. What times what gives us x squared? X times x. What times what? Then let's look at the last term. What gives us what times itself will give you a negative 7? Well, it may be kind of weird, but it's square root of 7 and square root of 7. And that'll give us no middle term. So we get x equals square root of 7 and negative square root of 7. A little bizarre. Okay, how about this? Let's set it equal to 0. And again, you haven't been able to factor the sum of perfect squares before. But I've recently shown you imaginary numbers, and with imaginary numbers, you can actually factor this. So what times what gives us x squared? X times x. What times what gives us positive 25? Well, first of all, since there's no middle term, these signs have to be the opposite. So right away, you should get a negative. But I know this is going to seem a little strange. What times itself will give you a positive 25 if one of them's positive and one of them's negative? 5i. That'll give you no middle term in the middle, and if you multiply it out, you'll find out that gives you a plus 25 on the end. So x equals negative 5i and 5i. Okay, how about this? X squared plus 7. And it's kind of a combination of problems 2 and 3. So we have x times x, and then plus square root of 7i and minus square root of 7i. So x is negative square root of 7i and square root of 7i. Kind of bizarre, but you can actually factor those. Okay? I know I've told you up until this point you can't, but that's because we haven't needed to, and it's kind of a little more bizarre than the things we did before. Okay, now I want to point out something, though. We could have done each of these a little bit differently. Actually, it's a lot bit differently, I guess. But anyway, this is what some people are going to do. And I don't particularly care for this method, but it's okay. It's not wrong. Okay, you're going to take the square root of both sides. Okay? Now you have to be careful. The square root of 25 is not plus and minus 5. It's 5 only. Well, what's the square root of x squared? I'm not going to go through the theory of all of this, but the square root of x squared is the absolute value of x. And then if I solve that equation, I get x equals 5 and negative 5. All right? So I want to point out the plus and minus 5 doesn't come from the square root of 25. Square root of 25 is only 5. But the square root of x squared is the absolute value of x, and that's where I get the plus and minus 5 from. I can do the same thing here. On the second problem, take the square root of both sides. Absolute value of x equals square root of 7. And then x equals square root of 7 and negative square root of 7. And at this point, you're saying to yourself, self, this is so much easier. Why don't we just do it this way? Because you'll make fewer mistakes if you do it the way I did it originally. That's all. And it doesn't take it much longer to do it the way I first did it. Okay, take the square root on the third problem. Square root of both sides. Okay, square root of x squared is the absolute value of x. Square root of negative 25 is 5i. And then we get x equals 5i and negative 5i. You say, wow, this is really getting exciting, Mr. Leblanc. When will it ever stop? So let's take this on the fourth problem. Square root of both sides. That gives us the absolute value of x equals square root of 7i, and then x equals square root of 7i and negative square root of 7i. All right? Now, why am I showing you this? If I'm saying the top way is better, the first way is better, why am I showing you the bottom way? Because take a look at problems 5, 6, 7, and 8. You can factor those, but you know what? Now it's kind of getting complicated. So on here, I'd probably do it by taking the square root. So I'm going to take the square root of each side, and we get the absolute value of x minus 3. Oh, by the way, I should say something, and then that's 5. It's perfectly all right with me if you leave out that absolute value step. You know, if you're doing it the second way, it's all right if you leave out the absolute value of x, but you should understand it's there, and the plus and minus 5 does not come from the square root of 25. Okay, it comes from the absolute value of x. All right, so if you leave out this step, the x minus 3, absolute value of x minus 3 equals fine, that's fine. So you have x minus 3 equals, and I'm going to put just plus and minus 5. And I could have done that on all the problems on the top too. Now, add 3 to both sides. I'm going to write something, but don't write this down. Some people are going to write this. I wouldn't. Why? Because a lot of people misread this as plus and minus 8. Well, that's not what it says, but a lot of people misread it that way. So to be a little safer, I would put the 3 in front. And, sorry, it shouldn't be a square root. Okay, and then, well, what's 3 plus 5? That's 8, and 3 minus 5 is negative 2. Okay, well, let's take number 6, square root. So we get x plus 10, the absolute value of that, equals square root of 7. So x plus 10 equals plus and minus square root of 7. And again, I'm going to subtract the 10, but put that first. And I'm not going to write this very much, but you should realize this is actually two numbers. Negative 10 plus square root of 7, that's one number, and the other number is negative 10 minus square root of 7. Those are the two things that make the statement true. And remember, that's all you're ever doing is finding everything that makes the statement true. Okay, let's take the square root of both sides. So we get x plus 9, the absolute value of that, equals 5i. Therefore, x plus 9 equals plus and minus 5i. And x equals negative 9 plus and minus 5i. And remember, this is negative 9 plus 5i and negative 9 minus 5i. Okay, next one, take the square root. It's kind of the same idea, just over and over. X minus 4, absolute value of that, equals square root of 7. Sorry, square root of negative 7, which is square root of 7i. And then x minus 4 equals plus and minus square root of 7i. And x equals 4 plus and minus square root of 7i. And I'm not going to rewrite that one. It's fine to leave it that way. Now, Alex is going to probably make you rewrite it as two things, which is kind of good because you should know that it is two things. All right. So what does this have to do with anything that we're doing today? Okay. Let's take a look at this. What we're doing is solving. All right. So this is all kind of background. Okay. What do? You make sure it's one side 0. Okay, I've got that. And you factor. So this is x minus 5, sorry, x plus 5 times x plus 5. And therefore, x equals negative 5. Now, it's negative 5 twice. You don't have to write it twice. But that's something called a double root. Or maybe it's also referred to as a double zero sometimes. That just means it's an answer twice. Okay, well, how about this one? Well, number 2. Good shot at, good luck at factoring that. It just doesn't factor. That's what we're doing today. This is what we're doing today, okay? What do you do when a quadratic equation doesn't factor? How do you solve it? And here's the idea. If you can make this problem look like 5, 6, 7, or 8, then you can just finish it off, take the square root, et cetera, okay? So I want to make number 2 look like 5, 6, 7, or 8, because they all kind of look the same, okay? All right, well, how do you do that? You do it by completing the square. Now, I want to point out something. When we completed the square before, I'm going to go back to it, this is what we did. Notice it was y equals, and at the time I was very emphatic, make sure you have y equals. Because in all of these problems, if you end up with y equals, you're wrong. Because what should your answer look like? Your answer should look like this. Your answer should look like x equals. So what you're trying to do is get x alone, okay? All right, so let's take a look at it. First of all, you already know how to do like half the problem, just so you know that, but only half the problem. Okay, so let's just factor it as normal. So we have 0, not y, 0. So we're going to separate the 1 from the rest of the problem. Then we're going to take the 10, cut it in half, and square it. And you should know how to do this, so I'm not going to go into a lot of detail here. And then because I added 25, I'm going to subtract 25 at the same time. And then I'm going to say x plus 5 quantity squared minus 24. Now, that looks just like this, doesn't it? Well, kind of, except there's a big difference. I don't want it to look like that. I want it to look like this. And by the way, it doesn't look like this over here. Why not? Because it doesn't say y equals. It says 0 equals. Okay, so what does that thing look like then? What it looks like is kind of like 5, 6, 7, and 8 here. The only thing we need to do is bring the 24 over. And now I just do the exact same thing I did here on number 5, 6, 7, and 8. So what do? Take the square root of both sides. And take the square root of both sides. And that gives square root of 24 is going to be 2 square root of 6. You know what? I'll put an extra step in there. No, I think I'll leave it 2 square root of 26. Or 2 square root of 6, sorry. Then x plus 5 equals plus and minus 2 square root of 6. And then I bring the 5 over, and again, I'm going to put it first. Negative 5 plus and minus 2 square root of 6. And don't forget, that's two numbers. It's negative 5 plus 2 square root of 6 and negative 5 minus 2 square root of 6. Okay? Huge difference between 0 equals and y equals. All right? Make sure that's why I was so emphatic before about keeping it y equals. Okay, and other than that, quite frankly, these are just examples. I'm not going to really tell you much new from this. Well, there is at the very end something I'm going to tell you new. But other than that, I'm not really going to tell you much new. All you got to do is complete the square like you did before, only since it's not y equals, but 0 equals, you're going to make it look like 5, 6, 7, or 8. Okay? All right. So let's take a look at this one. So we've got x squared plus 14x, and separate the 44. Okay, take 14, cut it in half, and square it, and you get 49. And by writing plus 49 there, I added a 49, so what do I want to do? I want to subtract 49 at the same time. I don't know why I wrote a 45, but Okay. So it's minus 49 equals 0. Don't drop the 0. Then we get x plus 7 minus 5 equals 0. Now, let's get x alone. So we'll move the 5 over. Remember, when we're done, it's got to say x equals. Take the square root of both sides, and we get the absolute value of x. And again, you can skip that absolute value of x plus 7 part. Equals square root of 5, and therefore x plus 7 equals plus and minus square root of 5, and then I subtract the 7. And again, remember this is two numbers, negative 7 plus square root of 5 and negative 7 minus square root of 5. Okay, here. Now I'm going to do it one way and then I'm going to show you something afterwards, okay? So I'm going to separate the 3 and the 12. Stick them outside of parentheses, just like we did before. Take the 6, cut it in half and square it. And that gives me 9. Now, remember, by writing plus 9, I was not, sorry, that should not be squared. Okay, by writing plus 9, I was not adding 9. I was adding 3 times 9. Right, because that 9's inside of parentheses with a 3 outside of it. So what was I really adding? I was really adding 27. So I'm going to subtract 27 at the same time. Now we'll factor, and that'd be minus 39. Okay, now let's get x by itself. We move the 39 first. A lot of 3's in this problem. Never noticed that. Let's get rid of the 3. It's outside the parentheses. And now take the square root of both sides. And then the absolute value gives us a plus and minus 13. Square root of 13, sorry. And then we'll add the 3. Okay? Now, I'm going to do this problem a little differently. And some of you may have noticed this, and if you did, it's good. I'm going to do it down here under number 6. So I'm going to cross out number, but don't you cross it out, because we're going to come back and do it. But I'm going to cross out number 6 for a second, because I don't have room to do it. But don't you put it down there. You know, don't put it in place of number 6. Okay, what else could have you done? Well, notice you have 3x squared minus 18x minus 12. And since it's an equation, big if there, if it's an equation, you can divide by 3. And then you'd have x squared. I'm just going to rip through it now real quickly. Take 6, cut it in half, square it, add 9. And now I really was adding 9, so I'm going to subtract 9. Then we have x squared, sorry, x minus 3 quantity squared minus 13 equals 0. And now I solve by bringing the 13 over. And at this point, it becomes the same as that right there. And then you would just finish the problem off. So if you can divide away that 3, that's great. It'll save you a lot of time. Not that big of a deal, though. Either way you did it is fine. Okay, let me get rid of this. Okay. Let's take a look at the next one. So again, what we're going to do is move the 5 and the 11 outside of the parentheses, just like we did before. And now what would you be left with? X squared plus 8x. Notice I couldn't really divide away the 5 because the 11 doesn't have a 5. Okay. So now let's, and by the way, I'm not, at this point, I'm just doing things over and over again, okay? Okay. So let's take the 8, cut it in half, and square it, and we get 16. Again, by writing plus 16, really what I was doing was adding 80. So I'm going to subtract 80 because that's 5 times 16. Then we'll factor it. And what's that? Minus 91. There's going to be something kind of weird about this problem, but it's not that big of a deal. Okay, then we'll subtract the 91. I'm going to have to think about this one for a second. I think I might have made a mistake someplace. I'll worry about it later. Okay. Okay, so we have 91. And then I'll divide by 5. Yeah, this one's just going to be a little complicated, that's all. Okay, then I'll take the square root of both sides. Now, what's this? The square root of 91 fifths. Now, that doesn't simplify it all. So I have to rationalize it, which I talked about before. So would have been nice if I had picked better numbers. But so we're going to multiply by square root of 5 over square root of 5. You normally don't have to worry about this. Okay, so we have x plus 4 equals plus and minus, and the square root of 91 times the square root of 5 is what, 455, I think? Over 5. Okay. Yeah, I think that's right. Okay, and then we'll just subtract the 4. Now, when I subtract the 4, normally you'd want to get a common denominator here. So we'll get a common denominator of 5. So we have to multiply top and bottom of the negative 4 by 5. So that's negative 20 plus and minus the square root of 455. Kind of weird numbers there, but whatever. Okay. All right, let's take a look at this next one. Let's, well, you know what? There's something I haven't done on these, and I probably should have. I did it on the first, on numbers 1 and 2, but I never did look to factor on these. And let me just point out, if you can factor these, okay, do so. Now, I'm not sure if I can, but I just noticed that taking a quick look at number 6, I might be able to factor this. Just look like it might be something I could do. So I'm going to give it a quick look, and if it doesn't work, that's okay, then I'll move on. So I know this is 3x and x. Okay, what will give me a negative 4? Let's try negative 2 and plus 2. Okay, that gives me 6 and negative 2. No, that doesn't work. Let's try negative 4 and plus 1. Okay, no, that gives me a negative 1. That's not going to work. I could try a plus 1 and a minus 4. That's not going to work. Okay, that's fine. I just thought it looked like it might factor. You know, because if you can, of course, if it factors, it'll be quicker just to do it by factoring. But it didn't. Okay, so let's separate the 3 and the 4. And that would be x squared minus 2/3 x. Okay. Now, why is it 2/3 x? And if you have a question, ask me. But notice over here on number 5, when I factored the 5 out of each, the 5x squared and the 40, how I figured out what went in the parentheses, I just divided each one by 5. Okay? So since I'm factoring out a 3, how I decide what goes in the parentheses is I divide each of those by 3. Now, a little lesson on fractions. And I've done this before with you, so it's not new. I did this when we completed this square before. What's like, I'm just making up different numbers. What's like 7/3 divided by 2? Okay, that's not how you write it. What you write is 7/3 with the 2 in the denominator. Okay, so 7/3 divided by 2 is 7/6. Okay, and again, I'm not telling you anything new. I've gone through this before with you. All right, so let's take a look at this. Take 2/3 and divide by 2. What does that give you? No, it doesn't give you 2/6. It gives you 1/3, because if you take 2/3 and stick another 2 in the denominator, the 2's cancel and you're left with 1/3. And again, I've done that with you before. Okay, so take 2/3, cut it in half. That gives you 1/3. And then square it. So 1/3 squared is 1/9. Okay? Now, when I wrote plus 1/9 with my pen, what was I actually adding to that side? 3 times 1/9, which is 1/3. So I'm going to subtract 1/3. Okay, so we have 3 times x minus 1/3. Again, first term, last term, check with the middle. And then when I add these, I get 13/3. Okay, so let's solve it. Let's bring over the 13/3. Divide by 3. If you divide by 3, you just put a 3 in the denominator, so that becomes 13/9. Now, at this point, take the square root, so we get x minus 1/3. The absolute value of that equals the square root of 13/9. Okay, what's the square root of 13/9? Take the square root of the top and the square root of the bottom, and you get square root of 13 all over 3. And again, it's plus and minus because we had the absolute value. And then if I bring over the 1/3, I get 1 plus and minus square root of 13 all over 3. And don't forget, that's two numbers. It's 1 plus square root of 13 over 3 and 1 minus square root of 13 over 3. Okay? That's it. Except for, how to do anything, that's it. There's nothing else. I want to give you some definitions, and then what difference do these definitions make? And I've given most of them to you before. The y-intercept is where the graph crosses the y-axis. The definition of y-intercept is not the value of y when x equals 0. That's how you find the y-intercept. The x-intercept is where a graph crosses the x-axis. It's not the value of x when y is 0. That's how you find the x-intercept. Okay? And all intercepts must be real numbers. Now, why am I mentioning this? I've defined before, but I imagine pretty quickly, what a 0 is. It's the value of x when y is 0 or equals 0. Now, that sounds an awful lot like the definition of an x-intercept, but it's not. Finding the value of x when y equals 0 is the way you find the x-intercept. Okay? Seems like a small technicality, and I guess you could say it probably is. But let me show you why it makes a difference. And I'm going to keep it for a fairly simple problem. I want to find, several simple problems. I want to find all intercepts in the zeros. Okay, well, the y-intercept for all of these is the easiest thing. You just stick 0 in for y, and you get 0, -7. You get 0, 7. I'm just sticking in 0 for x, right? On this one, you get 0, -3. And on this one, you get 0, 1. Okay, to find the x-intercept, we stick in 0 for y. Okay? And I'm going to do this fairly quickly. Okay, so I plug in 0 for y, and I factor this into x minus square root of 7 and x plus square root of 7. So my x-intercepts are square root of 7, 0, because remember it's a point, and negative square root of 7, 0. Fine. What are my zeros? Well, it's the exact same thing in this problem. I stick in 0 for y, solve for x, except it's not a point, it's just a number. Again, that's a small technicality. Okay, so let's take a look at the x-intercepts. Plug in 0, and now I showed you back at the beginning of this video how to factor this. It'd be x minus square root of 7i and x plus square root of 7i. Okay, but then, therefore, there are no x-intercepts. Why? Just think for a second. Where on an xy axis system are the imaginary numbers? There aren't any. They're all real numbers. Okay? And if you think about it, where does x squared plus 7, y equals x squared plus 7 graph? Well, it's an x squared graph shifted up 7. We know there's no x-intercepts. So we know it doesn't cross the x-axis. And how could we figure that out just by calculation? Is because the numbers I got for the x-intercepts were imaginary, and there are no imaginary numbers on a xy axis system. So what are the zeros? Well, I do the exact same work, but the zeros are negative square root of 7i and square root of 7i. What's the difference? Look at the definition. A 0 is just the value of x when y is 0. It's the value of, I can plug in for x that will make y 0. And if I take square root of 7i and plug it in for x and x squared plus 7, it'll make y 0. And if I take negative square root of 7i and plug it in for x, and so I take that number, square it, and then add 7, I get 0. So those numbers make the statement true. That's why they're still zeros. But they're not x-intercepts because they don't plot anywhere on an xy axis system. There's no imaginary axis. Okay? Again, it's a small thing, and I understand, but make sure you understand that. Okay? So for instance here, let's find the x-intercepts. Okay, well, I'm going to plug in 0. And here, that's not going to factor, so I'm going to complete the square. So I'm going to take 12, cut it in half, and square it and get 36. So I subtract 36 at the same time. So I get x plus, and I'm going to go through this quickly because I'm just trying to prove a point. And now I'd solve for x. Take the square root. So you get x plus 6 equals plus and minus square root of 39. And then you get x equals negative 6 plus and minus square root of 39. So what are the x-intercepts? Negative 6 plus square root of 39, comma 0, and negative 6 minus square root of 39, comma 0. Okay? Then what are the zeros? Well, it's just the number, negative 6 plus square root of 39. That's one number. And negative 6 minus square root of 39. Okay? All right, well, how about this last one then? Again, I can't factor it, so I'm going to put 0 in for y. And again, notice here I'm putting 0 in for y. What allows me to do that? Because it says, find the intercepts and zeros. I'm telling you in the instructions, do it. But y equals 5x squared plus 3x plus 1 is not the same as 0 equals 5x squared plus 3x plus 1. It's only because I told you, find the x-intercepts, find the zeros, that allows you to stick that 0 in for the y value. Okay, so we're going to take the 5 out, and we have x squared plus 3/5 x and plus 1. Take that, cut it in half and square it. Take the 3/5, cut it in half and square it. And we get, okay, if you cut it in half, you get 3/10. Okay, square that and you get 9/100ths. Now, when I wrote plus 9/100ths, what did I really add to that side? 5 times 9/100ths. Okay? So what am I going to do here? I'm going to subtract 5 times 9/100ths, which would be 9/20ths. Okay? Now let's factor it. And get a common denominator. 20/20ths minus 9/20ths is 11/20ths. Okay. Now let's bring over the 11/20ths. Divide by 5. Sorry, that's wrong. I shouldn't have put the absolute value on it yet. It's still quantity squared. Take the square root. So we get the square root of negative 11/100ths. Okay. Now, what is that? Well, the square root of negative 11 is the square root of 11i. And the square root of 100, of course, is just 10. And then all I'm going to do is subtract the 3/10. So I have negative 3 plus and minus the square root of 11i all over 10. All right? So what are your x-intercepts? There are no x-intercepts because these aren't real numbers. But what are the zeros? The zeros are negative 3 plus square root of 11i all over 10 and negative 3 minus square root of 11i all over 10. Why? Because if I substitute either one of those numbers into the equation for x and calculate it, you'll get a y value of 0. Okay? Does anyone have any questions on that? All right, in which case it looks like we're all out of problems. Kind of a sad moment, but it is what it is. Have a great day, everybody. Bye-bye.